morning, gentlemen. This is the video I promised you on the control scenario. I will be making one for the motor control scenario also today. They are fairly lengthy, so I'm going to try to keep this one under 15 to 20 minutes. But there was a lot of good stuff on the first attempt that I wanted to make sure I had. What you're looking at is the motor control board. You should be familiar with that because you watched the 5-minute video that demonstrated and showed you all the various things. What I have is I have it pre-set up for my connections that really don't have much to do with the control scenario. The reason that we need to bring the starters into play is because we do have the power for the lights hardwired through the starters. So where your control scenario won't include starters, it'll just include the timer. We just have to realize that these are like auxiliary, and that for the scenario to work the way that I want you to draw it, we would have to unhook the leads coming into the lights and just hardwire them, the neutrals over to this neutral spot, and the two hots over to the switch legs we're going to use. Because I don't want to undo this, I spent a lot of time building these. We're going to leave it like it is, and we're just going to control the starters to turn the lights on and off, which is going to be somewhat loud and maybe a little startling, because as soon as I put power to the board, one of the lights will turn on automatically and it'll make a loud noise, so just be aware of that. So for our control scenario with the railroad lights, we are going to use a relay and a timer, and we're going to use some inputs. Now, we all been at railroad crossings. We know how they work, right? A train gets close to the crossing, it sets off a sensor, and that starts the program where the arm comes down. There's a bell that goes ding, 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 and then the lights alternate. And we're only worried about the lights, even though the bells is kind of the same thing, right? It would be an alternating control scenario. We don't have sensors, railroads. I'm not outside, so we have to use our imagination. We already are using our imagination to eliminate the starters, right? Those are just in here because that's the only way we can turn the lights on and off. We also need to use our imagination for our inputs. If you've gotten yourself familiar with the PLC software, I'll just use some of that. So we need two inputs. We need an input that is the railroad sensor that senses the train coming, and we need an input that gets set off as the train leaves, right? So input 1 and input 2. In the software, we've always used input 1 as our stop button and input 2 as our start button, and so that's what we're going to do. We have a stop button. We're going to use the forward button on this push button station. All right, the other things we're going to use is our relays, our ice cube relay and our timer relay. Okay, so just as a precursor, just as a way to understand how the board works, I'm going to show you how power flows through. We have our plug. I have it plugged into a power strip. It'll make it so much easier for me to turn the board on and off and streamline the video. But basically, if I want to get power anywhere, I just plug into this loop of wire and say I could just bring it right over here, and as soon as I plugged in or turned on the board, the light would come on because I would be applying 120 volts across the coil. No, we're not going to do that. We're just going to move power over to a forward button, because I want to show that happening. As part of my prep, I already provided myself with switch legs for the motor starters, because like I said, the motor starters are really something that we're going to use our imagination to eliminate. But this is kind of a spoiler alert on the motor starter and how it works. With this hookup, when I put power to it, in order to turn the light on, all I have to do is hit the forward button. So hopefully you see that, but I'm going to show that work by coming over to this side, turning the power on, and pushing the forward button. So this is our basic. We're controlling it. Okay. Now, if we wanted to just control the light, we could actually just put that neutral to the light and that one to the that neutral to the light and that one to the coil, and it would work. Sorry, I had a little epiphany. I'm not going to do it here though, but a way that we could avoid using the starter and still make it work. Anyway, so turn that off, safety first. That is simple. That is how we simply control a motor. Motor starter. So we're going to undo this switch leg. This switch leg is going to be controlled by our timer, right? Because we want it to alternate. And so we're going to leave those to the side and we're going to start building the circuit. Okay. First thing, we take our lead and we want to come into the stop button first because that's our input 1. And you can't see it, but it's labeled in and out, in and out. So we're in stop 1. And we're going to go out of stop and in to forward. And this is just like building a branch circuit, a daisy chain. So that's all I've done, with one exception. The power coming over to the forward button can be broken if I push the stop button, right? The stop button is normally closed. So right now it would allow electricity to get all the way to the common side of the forward button, and we'll just call it start button from here on out. Okay, so now I have a scenario. If I were to plug this in to the switch leg side of the forward button, I have a scenario where I can turn the light on with the forward button, but if I push the stop button, I've broken the circuit. Now if I let go of the stop button, the circuit closes and it's open again. Let me close the circuit again. If I lift up on the forward button, now this is normally open, so when I lift up on the stop button, nothing goes through. So that's just a little taste of what we will be doing with the motor control scenario. However, we're doing the railroad light control scenario, and so we need to utilize the relay and the timer relay. But I just wanted to demonstrate how our power circuit gets built. Okay, now you have to take the relays off and give you a brief overview on our relay. Obviously, we have our diagram. The numbers on the diagram correspond with the screws. Okay, so we're going to look at our diagram, and in order to energize this relay, our coil numbers are screw number 2 and screw number 7, right? So most of the time coils are labeled A and B, so you will see that from time to time. This one doubly labels it A1 and A2, and I think that's how these are labeled too. A1 and A2, but coils are usually labeled like I showed you before with the little coil symbol, and I don't know how clear that's going to be. So we need to look on the base and we need to find our hookups. So that's this way. So 7 and 2 are right here. Then the other thing we need to look at is what are our dry contacts. Okay, so remember I've written out in some other material that the relay has dry contacts, and what we mean by that is they're contacts that don't have any, they're not energized at all. You have to provide the power, and they're usually set in pairs where you have a common and then a normally open and a normally closed. and then there would be two sets. So this would be a common, a normally open, and a normally closed. Just like a three-way switch, right? We made that connection. So we want to find our common, which is screw number 1. And you know what? This might make it easier while I have it down, is I'm going to just raise that one up. And then we want to find our normally open, which is 3, and that's this one right here, normally open. So I'm going to raise those up, and I'm going to plug this all back in. And put it back on the DIN rail. Okay, now we are controlling the relay with our start button because we have to build a memory circuit. And if we built a memory circuit with the timer would keep breaking its own memory circuit, and that really wouldn't do what we needed. Okay, so we need a relay circuit with a timer relay. So that's our switch leg, and we need a neutral, right? So remember, the two outer ones were our coils, 2 and 7. And you know, I could really tie this anywhere to any neutral. So, but just for sake of you know, simplicity, I'm going to just tie it to the neutral that's coming from the plug. Our switch leg is going to go over to the other side of the coil. Okay, so now we have a scenario where instead of controlling the starter, I'm controlling the relay with my switching. In the previous video, I showed you how all of that works. The next thing that we have to do is remember these are dry contacts. And so I need to bring power from somewhere. And it needs to be power from somewhere that's going to get broken by the stop button. So we're going to put it on the input of our start button. And remember, I raised that up. And that's our common, screw number 1. Okay, now just take any one of our switch legs, whichever light we want, and we can tie it over to our normally open, which is 3. And now we have a scenario where if I push the start button, it's going to actuate the relay, and that relay is going to then power the starter. If I push the start button. But as you can see, when I lift up on it, it shuts off. Same scenario, right? If I hit the stop button, it breaks. Lift the stop button, it breaks. So we need something, right? We need a memory circuit. Okay? And this is the part where people do get confused. And I'm going to do this from this side for the interest of time, but I use yellow for my memory circuits. Always. I try to color coordinate as best I can. Black for constant power, white for neutral, red for switch legs, yellow for memory circuits. It just helps me. So this is the big aha, okay? In order for my relay to stay energized after I release the start button, all I need to do is bring power back around from my normally open contact and bring that into the power side, not the neutral side, but the power side of the coil. And as simple as that, now I've provided a memory circuit. So let's see. If I hit the start button, it all stays on. Okay? And that's just because power is traveling through this loop. So let's follow the power. We're coming from the switch, from the plug lead. We're coming over through our stop button, which is closed, right? We're coming over and providing power to the switch. Then we're taking power off of that same input and bringing it over to our common on our dry contacts. Okay, so that power's going there. Once the relay closes, it goes over to the normally closed contact, which is what I've got powered here. I've got 2 leads, one going to the starter, which is turning the light on, and one that's coming around, and that power's feeding around and feeding the power side of the coil. So if I hit stop, it all stops. If I hit start, it's all open. Now take your brain and remove the starter from the scenario and just imagine that we're just plugging the wires from the light. So we're just plugging the switch leg of the light in. And you've got the beginnings of the control scenario. So stopping, and now we're going to add the timer in. Doing good. All right, so the timer, we're going to need to take the light off of the relay, because the timer is really what's going to control the lights in the end. So everything we have built can stay, but you saw that I just took the lead off of the starter. And in order to get going on the timer, we totally have to look at it. We have a diagram, just like we do on the ice cube, and everything's numbered, and we have our base. So we have to make these numbers match. To power the timer, or the computer board in the timer, it says we need to put 120 volts from screw number 2 to screw number 10. So let's find 2 and 10. Raise those up. 2 and 10. Okay. And then we're going to control the light, or the starters, right? We're going to control the lights with the timer, so we need to find our set of dry contacts. And in this case, it's the same as our relay, number 1, 3, and 4. So I'm going to find 1, and then 3 and 4. And so now everything is raised up there. So I am going to double check. I don't want to hook it up wrong. So now I've got all of the loops up that I need, and I'm going to go ahead and plug this all back in. Put it on the DIN rail. Okay, so our switch leg is still going to be going into the relay because we need our memory circuit. But now the switch leg that we had going to the motor starter is going to actually come around and hook up to screw number 2 or 7. It doesn't matter. Okay, are we missing anything? Well, yeah, we do need a neutral, right? 120 volts. And again, I want to avoid confusion, but you can hook that neutral in anywhere. So I'm just going to tie that neutral power around, and actually that's it right there. Had it hooked up well. Alright, so now I have a memory circuit that's going to control my timer. Now the only thing I need to do is I need power, right? And I did actually run out of black leads for power, so I'm going to switch over to green. And this power can hook up anywhere where there's power that will be broken by the stop button. We're going to just tie it right to our normal, and we're going to provide power to the common side of our dry contacts on the timer. Alright, so now we're to the grand finale of how we hook these up. We have these 2 switch legs coming from our starters, so we are going to just go ahead and we're going to hook it up to the normally closed one, which is number 3 here. Now I've only got one light hooked up, and what will happen is if I were, and I'm not going to do this, but if I were to hit the start button, this light would flash, or it would be on delay. Maybe I'm going to do that because I did show that in the last video. So this is where we get to the programming part. You have several programs on your timer. I don't know how well you can see this, but this is how you change it. I'm going to change it to program A, and then you do your seconds and time range and stuff here. Okay, so now I've set this timer. You have to take my word for it. I've set it for on delay and 3 seconds. So I'm going to plug that timer in, and I'm going to put power to it. And what should happen when I hit the start button, forward in this case, is that the light should come on after 3 seconds. And it did. So now let me show you something. If I were to use the timer to create my memory circuit, it would be no different than me hitting the stop button before the 3-second countdown. So forward. Oh, see, nothing happens because the timer doesn't have time to run its program. So that's why we need the relay. Okay. Now, if I wanted to get this one light to flash on and off, all I need to do is change the program to repeat cycle. And I could use on or off, and it didn't matter. But let's try on, because you know it may matter. And we're going to let that flash at a second interval. So right now, if I hit the stop button, so I got the one light, and it's going on every second. And if I hit stop, then it'll shut off. So what do I do for the other light? Well, those dry contacts come in pairs, don't they? So I have a normally open and I have a normally closed. Right? And right now I'm hooked up to the normally open. But what if I just hooked this up to the other side, to the normally closed side? When the timer switched over, theoretically it would be sending power to the other contact side, right? And this is in fact the control scenario. So let's go ahead and test that. Like I said, when I turn this on, it's going to pull one of them in, so it might be loud. Actually, that was good. I talked through it. Okay, so obviously with the light coming on, we need an extra level of control to completely imitate our railroad signal. The only real way to do that would be for us to have a like a mushroom that's not a momentary contact button. But with the way I've got it set up, if I hit the start button, my cycle will start and my lights will alternate every second. And there you go. That's the control scenario as it's hooked up on the board. Stop, shuts the program off. Say I wanted the lights to alternate a different way. Well, I could just switch these leads. So now the red light would come on as soon as I put power. And when I hit start, it would go back and forth. So hopefully that helps. Helps you figure out, how to draw it. Like I said, in the instructions for the project, you have a relay and a timer. And I wasn't going to be any more specific. I guess I could have said 1 and 1. But just remember, just as a reminder, the starters don't need to be part of this scenario. If we took and just wired in the neutrals to the neutral and then took our switch legs from our lights in, that would work the same. It would be a lot quieter. So hopefully you've enjoyed this. I got one more video to make, and we'll see you. The plan is that you'll get to come in and do the labs like a week or two before the next semester starts. So thanks a lot.